and it is recording is started. So welcome all developers of the UAP Tracking Forum. The today's session is about the core software concept. We were internally discussing the concept, a couple of people, several sessions, but it's still a raw concept. And we want to use your contribution and your discussion and ideas. And maybe we missed something, maybe we're missing something out, or it's not well explained, or make more details to it. So please share with us your thoughts. Although I will present it, I actually expect you to jump in with questions right on spot. So there's no question and answer afterwards. The first hour today is for the software concept only. Then we do a 5-minute break, and then we have 1 hour machine learning special hour. So whoever wants to stay on, you can stay on the whole time. You're very welcome to do both sessions. But the how you say, the theme is different. So first of all, we talk about the software concept as such, and then we do a non-special on the machine learning. Okay, I try now to share my screen. Any questions up to now? Okay, I'm not sure whether you can hear me at all because no peep it yet. Okay, I'm gonna share my screen. All right. So, do you see my stream? My stream? Christian, can you see what I shared?
Yes.
Okay.
But maybe you have to scale to enlarge it to full screen.
Yes. Better?
Yeah, much better.
Okay. Brett, you can see it too. Yeah. Okay. Great. Thank you. So this is a schematic view of the software concept of the system actually. We think about the sensors that we put in 2 levels. We call some the master sensors and we call others slave sensors. The main difference is that a master sensor is running more or less 24/7. Let's say, for example, the old Sky Cam scanning the hemisphere on a 24/7 level. A PTZ camera, for example, is a slave sensor because it only comes then into play when one of the master sensors detected something, then a slave sensor is, or all slave sensors are activated. So we define this hierarchy, and we think it's very logic to let control this play between master and slave sensors and activating those events and deciding on events and prioritizing and so forth, to do all this stuff in an extra software, calling it the master control program. So any one of you who is still older than 40 will probably understand what the master control program meant in history. It is actually a piece of software that is running by itself, for itself, controlling all equipment within a station. So what you see here is the 2 sensors, which we call the old Sky Cam sensor and the PTZ Cam sensor, but you also see other sensors like a Kerberos SDR. Do you see my mouse if I move it over? Okay. So these are master sensors. We call this the old Sky Cam, and this is the Kerberos sensor. And maybe there are others in the future. On the slave side, we have something that is pan-tilted, also like a pan-tilt cam. It's a PT dish, for example. It's like a satellite dish that you move to a direction where you want to point it to. So, and then we have components that are, let's say, not sensors. Let's say a user interface. We call it very abstractly here a GUI, and Christian will go into detail afterwards. There's also a component like a climate control component, a piece of hardware and software that controls the internal climate, and also Christian will afterwards go into detail why this is necessary. And then we have, of course, something that is a central storage device. Our proposal is to use because it's the internal component, the backbone is a local network. It's a LAN, and that's why it makes sense if we have multiple sensors on masters and slave level. We need a centralized storage where the storage process is not interrupted by a dedicated hardware, let's say, to do everything on the Jetson Master, for example. So that's why we propose here something that is external. And then we have a cloud component. So this is actually very easy to read, I hope, because of the separation of these components, let's say the master components and the slave components and the external components. Those components have connections, and we call them as what they do in 4 different colors. So we have a communication channel, we have a data and a signal transfer channel, and then we finally have a data file and the backup arrows, directions, channels. I would say I hand over to Christian to go into detail about the software from now, knowing about what the components are into details of those components. But please, again, if there are questions, please just drop them as they come in. Christian.
Okay. We decided that it is a good idea to have a Jetson Master and a Jetson PTZ divided and not running on the same hardware. These are the green boxes, and let's start with the Jetson Master. Richard, can you full screen the schematics, please?
The hardware schematics.
No, the concept schematics. It's not full screen anymore.
Okay. This is the sharing component. I have to stop this again, the sharing.
Yes.
I know this. I know it would happen. So I have to put it over here. No, actually, the thing is, I'm on recording, but I want to have this also on recording, but it does record only one screen and not the other screen. So I have to bring it over and share this screen. I hope this works now. And bring this to the 4th. Do you see what I see? Do you see the schematic?
Yeah. This looks good.
Okay.
Okay. So on the master sensors, we have got the Jetson Masterboard, and as Richard already explained, we've got the MCP, the Master Control Program, on the one hand, and something that we called All Sky Cam. Under All Sky Cam, we understand that it is not only a camera, but the camera stands for all sensors, and the main part of it is the camera. So since we've got experience with astronomical device controlling, we thought about it very much and said, okay, the INDI Protocol, INDI stands for Independent Neutral Device Interface, would be a good solution because it's developed for 25 years now. It's made very good use in amateur and semi-professional astronomy, and therefore provides many of the applications that we want to use, like cameras out there. Most cameras that are used are already used in amateur astronomy. There are several companies that provide good cameras with good resolution. So we've got the camera, then we've got the Geophone, which takes seismic data. Then we've got the EMF part for whatever comes with that. Then we can attach a weather station, accelerometers, and GPS, and maybe some others. Let's call them auxiliary sensors. They are all connected to the INDI server that provides a protocol as a service. And since we are referring to the software only, INDI provides us with all the interfaces we need. That's why we choose it. And it has got a Python layer and a very good documented API too. So we can write our own modules for it. We can write our own GUIs for it. That won't be a problem because that and the life cycle, the duty cycle for updates with INDI is 2 months. On a 2-month basis, everything that is developed for it in that period will make it to the actual version. So because this is long time developed and will be developed, I think, for the next 15 years maybe, since there's a need for it, it is a good point to start. It provides every sensor that we want to use, and therefore we made the decision to go with INDI. Another point was that INDI also is running on Linux, and since the Jetson boards have their own Ubuntu system, it's no problem to integrate it, and it's made for it, I would say. The INDI protocol in here, as indicated, is some kind of hardware abstraction layer, and that then we have got an event management. In the event management, all data comes together, and if let's say we take out the camera as an example, the video stream is image processed and analyzed, and with machine learning capabilities we can detect movements in it, and therefore we can trigger something that we call an event, and this is directed to the master control program. The master control program decides, according to the labeling and the classification, if it is an interesting event or if it is something that is already known and considered boring. If it's not boring, then the event is triggered, and the data merging begins. So data merging means that all the sensors come together, and their single signals are processed, and a complete data stream is generated. If the machine learning thinks this is, let's say, we put a focus on UAPs, and then if the master control program thinks it is an UAP, some kind of vectoring starts, like coordinates are measured, and therefore a movement path is generated that we call vectoring, because it already are vectors. We trigger, or the MCP triggers that the PTZ Cam will slew to it, and the connection is done by the bt³s thing, we call it here. bt³s stands for Be There Telescope Tracking System. I developed it to control my own telescope in a very, very agile and precise way. The connection to astronomy again. Therefore, we can move the camera very, very fast around. The one point was that we could track the ISS, and we will use the ISS tracking as some kind of measurement if anything of the concept will work. Yeah, as a benchmark. It is not The master control program doesn't talk to the event management like in AllSky, because we need a very, very direct way to talk to PT control in this case. PT control controls motors, encoders, and the inertial system that we use to determine where to point, and how to slew, and how to calculate how the fastest way to slew to any point. MCP talks to bt³s. bt³s shares the information, triggers via the INDI protocol the camera, maybe some filter wheels, or anything that is connected to it, and then talks to the event management where the image processing is done in the way the AllSky Cam does it. So we reuse the code. The code is installed on both Jetsons, and the classification and the labeling part that's done by machine learning is done too. So that we can, let's say, find out if the spotted event is a plane or the ISS or maybe a flying saucer. We do not know yet. So after that, then the event manager talks back via bt³s to the master control program and says, okay, we detected here something. Then the master control program talks to all other connected systems, and the archive management is triggered. In the archive management, every Jetson board, every sensor provides its data and stores it in the database that we provide via the MCP. For the and that is stored on the mini NAS. As a mini NAS, you can think of it. There are several ways to do it. You can use a Synology with, let's say, up to 8 hard disks, SSDs for the speed, or you can use a one case mini NAS with one SSD in it. These are the data files produced, and they are backupped to the cloud afterwards for further analysis or whatever we want to do in the future. Let me get to the point where we talk about the database. We thought about it, and since the real-time event tracking is necessary for us, we decided to go with a graph database like Neo4j because it's real-time enabled, and it brings there you do not have to search for the data, because the path to the data is stored with the data. So you can keep track of it, and that enables real-time management. So, did I miss anything? I don't think so. Yeah. Okay. The GUI and the enclosure air conditioning. Since we do not want to have a local GUI for it, where people may alter things, we will provide a two-step or two-phase GUI. One GUI is just for watching. This will be set up as a web front end mainly. But for maintenance purpose, or if you are in a remote location, then you need some kind of controlling mechanism. Therefore, there will be Python, PyCUDA, no, not a PyCUDA, PyQt6 GUI that can be run locally. The main GUI that we want to implement is just for viewing the status, for viewing what the all-sky camera sees. In case of an event, the PTZ Cam will light up and give its information too. And we want to display all the sensors, all the sensor readings too, so that we can get a very, very full-scale view of the things. Yes, comprehensive. Then we've got the enclosure air conditioning. We need that because the enclosure gets heated up by the sun, even if it's very cold outside. If it's very cold outside, like freezing temperatures, then the humidity can become dew and freeze on the electronics, and that's not good for them. So we have to keep it below 0 degrees Celsius. And we don't want any dewing on the lenses, because then we can't see anything. So we and we do not want any flow in it, because that creates seeing disturbance in the air that reduces the image quality too. So therefore we try to set up a very, very good air conditioning system that that takes care of all those things. And this is done by the master control program as well. I think I missed just one point of the master control program. In case there are multiple events happening, let's say a bird, a plane, a UAP, then some kind of prioritizing has to be done. Because you can't direct or slew the camera to every of the to every event at the same time. So if the prioritizing is set to, let's say, UAPs, because we want to look at UAPs in the first place, then it decides that, let's say, the plane and the bird are dismissed for the event handling for the PTZ Cam. If we provide it to people that like to watch birds in the first place and are not interested in UAPs, since it's our station to observe UAPs, then the prioritizing will be done first the UAP and then the bird, and then every other thing. For plane spotters, it will be the same. So in any case, the UAP has a master priority. Okay, go ahead.
No, I just wanted to say that there's one master priority, exactly what you said.
Yes. And I think that's all I can say at the moment for the concept. Any questions?
So
I know it's not a question, but thanks for that wonderful presentation. So even someone like I can totally understand how this should work.
okay, thank you. Are there any questions? I put it over here. Is it still shared to you? So I'm not sure whether you can hear us because you're all muted. I don't know how to unmute you. Are there really no questions? I can't assume.
I have a very simple question. How much do you already have a cloud solution?
No.
And do you know how much? Okay.
No.
I wanted to. My second question would be the costs
Yeah.
associated with that.
We had a cloud solution with SkyHub, and it costed a lot of money. So we had about $400 per month to cover. And so all the people within the organization were always running about getting money in. So this was so crazy. And we decided with Sky360 not go that route. So we want to set up the system as is first. And when it's creating real good data that we want to back up in the cloud, then we look for the cloud. Let's say not within the next year. Let's say maybe by end of next year.
Yeah.
So for now,
the thought is that we focus on getting the first images and then thinking of where to store it. We can store them locally at any time because we've got the mini NAS, and just backing it up from the mini NAS to the cloud will be an easy thing. So I don't think that we have to think about that now.
Yeah, makes sense.
Yeah, it just involves unnecessary costs, and at the time when we don't have the data to work on, it doesn't make sense. Yeah, and if we do this, the next step is, of course, logically to implement tools to work with that data. It's not just a data storage. That doesn't make much sense. So there has to be some platform around it, so to make it accessible for people and so forth. And also, we have to implement a process, what we call the DANA, the digital, what is DANA standing for? A non-disclosure agreement, kind of. Meaning you have to sign a non-disclosure agreement before you get access to the data. It's illegal, although the data is open to anyone can file such a DANA. We just have to keep it in the books with a signature. Because of legal issues, because we are issuing data which can inflict privacy. Could, does not necessarily have to. Yeah, and those issues we postpone it to the future. That's it. So for now we focus on the main parts. Let's say the main parts for now are the master control program, and of course the all-sky cam, and the GUI, and maybe Bojan can start whenever he wants with the enclosure climate control. The NAS is just established, easily established by the user. The PTZ stuff will come up when
this is like early development.
Hey, that's an easy fish for you, Bojan, isn't it?
Huh?
That's an easy fish for you, isn't it?
Well, it's not easy.
Maybe let's talk about the development experience everyone has that want to contribute. I can start with what I want to do. In that concept, I want to focus on the INDI part, and I have experience with programming GUIs, but I want to mainly focus on getting the sensors, especially the cameras, online with INDI. And since I developed bt³s myself, I think that part will belong to me too. But if there are anybody who want to take part, is welcome. So if we can create some kind of wingmanship so that nobody has to do things alone, I would appreciate it.
Okay, this brings me to a good question. Since people are online here, and I hope you're not only muted but can talk too, I would like to hear your ideas, where you think you can contribute, or where is your emphasis pointed to? So we get an overview, what you are doing, what you want to do, what you want to contribute. Anyone starts first?
Okay. Hey guys, it's Paul.
Hey, Paul.
Firstly, thanks for putting that together. That's very interesting. Not necessarily questions for you guys, but areas that I need to look into a bit more to understand it would be the INDI, how that integrates with OpenCV or possibly DirectStream. The other bit that I'm not particularly familiar with is GraphDB, although I'm familiar with GraphQL and SQL and PubSub sort of architecture. I haven't used the
Neo4j is written in Python and makes heavy use of Python. So we want to focus on Python as a programming language, and therefore we the INDI protocol uses Python, and most other things do too. So Python is some kind of essential here.
Yeah, and the only I wasn't suggesting anything else particularly. My only concern would be around performance, especially on the Nano.
Yeah. We will try to implement everything as fast as possible, maybe using sequencing and parallelizing most of the stuff. For the image processing, we thought of making use mostly of the p-frames of the video stream. So that reduces things to certain apertures. And for the PTZ, we're using apertures too, so that we do not have to work with a full frame on the image processing. Since the Jetson Nano, I think it has 3072 CUDA cores, that won't be really a problem, because if we put in, let's say, 300 pixels and not up to 4K, that won't be a problem either. So we have to see. Pardon?
Sorry, Karen.
So we have to see what has to be done about multi-event detection.
Do you have a proof of concept for that?
Not yet, but we will start in the next week to see how the workload will be for the Nano with the all-sky cam that we set up right now. We've got ZWO RZ100 Mini attached to 60 millimeters fisheye camera. And this will be the first step to see what amount of data we will get.
Yeah, I mean, I'd be interested in the performance characteristics of something like that. The other thing to consider is that a lot of the image processing that we're doing will require a lot of the full frame stuff. So you end up recreating the full frame anyway. So, although the P frame is going to do reduce your bandwidth, you're still going to end up reconstructing it, which is a load on the CPU or the GPU.
Yeah, that we have to determine. That we have to determine. I do not know that yet, but we are on it, and we try to make that available as soon as possible.
Cool.
Hey, sorry.
The INDI protocol is so nice that it provides even the possibility to use the Dahua camera, so that old SkyHub stuff isn't lost, and we can reuse the hardware too. And that was a main thing that we thought about too. And yes, about the performance, I have to look what the camera and the actual TIS cam can do, and how it consumes resources.
ppbitb wanted to ask something.
Yes, thank you. I guess my question, and maybe I'm not knowledgeable, I didn't read any resource around the hardware, but what is the basic hardware that's needed to be helpful, to contribute to the project? Do you need one or both Jetsons, and what about the GUI and things like that?
Richard, will you answer this?
We we start with the nano. And we had this discussion, Christian, remember, whether the nano is sufficient enough to do so. Actually, we don't know yet. We can't say it for 100%, but we think it could be sufficient. At least we have the possibility to tweak data before it comes in order to reduce load on the board. So meaning that a nano maybe processes lower resolution videos than Xavier, for example. But in any case, a nano will certainly be supported.
I've got some experience with Raspberry Pi 4s with 4 and 8 gigabyte, and they handle especially my RZ1600 Pro camera with 16K, and that nicely. The video stream is very well prepared and analyzed by a Pi 4. And the Jetson Nano, I think it has much more power to do that. So my guess is that it can do that. It's since it's running on a Raspberry Pi 4 already.
So that's for the kind of the performance of the hardware.
Yeah, so we start with 2 Jetson Nanos, one for the Master, it's called Jetson Master, and one for the PTZ Cam. The PTZ Cam needs its own to control things because we need it for the mounting and the tracking system that has to be very agile, so that we can't, that would be too much workload for just one single nano. So we say we use two nanos, and for the camera, we said that at least 12 megapixels should be used so that the ISS will set up to 28 pixels.
Okay, but for example, can we emulate the camera? You know, can we have some files that match what the camera, data would be and work off of that? Or do we need an actual camera with those specs?
No, you can use any USB plugged webcam for it, because the INDI Protocol provides video for Linux access, and therefore you can use any for the development any camera you have on hand. But we will set up a camera that we want to use as a basic one and provide that. But for the development, any camera will do.
Would it
Okay,
even
thank
be
you.
possible to tell INDI to take a folder of video files, existing video files, and stream them?
If we integrate GStreamer into it as, let's say, a camera simulator, yeah, so we need one who will implement that. That may be useful for setting up unit tests too.
Okay, and it's because the INDI is written in Python, isn't it?
I think it's written in C++, but makes use of Python too, okay, because Python is just the scripting layer of C.
So anyone can contribute by adding
yes.
A GStreamer on the Python way. Okay.
Yeah.
So I'd be very careful about suggesting that people purchase nanos at this point.
Yeah.
For everything that I've looked at, a nano is underpowered. Looking at the specs of the nano, it's 128 CUDA cores, which is
okay,
absolutely tiny. And it doesn't have some of the hardware acceleration for the optical algorithms, some of the optical algorithms that we're looking at. So, I mean, I'd much rather have, and the other thing that concerns me is having the MCP on the nano. I know it makes things a little more complicated, but I'd much rather have the MCP like a Pi 4, for example. Because if you're going to be, where's the GUI? Where's the back end for the GUI? Is it that MCP?
We at the moment we consider having the GUI run on the CPU of the Nano. Yeah.
Yeah. So if you're going to run the GUI, the MCP, and the all-sky cam on the Nano, I just don't. From what I've seen of its performance, I don't see how that's going to work.
Yeah, we have to look what we can make out of it.
Yeah, so it could be that the Nano is really not sufficient. Because we didn't implement this yet, Christian is going to implement the INDI on a Jetson Nano in the coming weeks. So at that time we will know what performance is possible on the Nano. And if you're right, if the load is too high for the Nano itself, then we have to put the MCP on another board, maybe on a Pi, for example.
Yes.
Anything.
Yeah, the thing that concerns me about the GUI is it has bursts of high activity, right, which can then affect other things that are running on that machine. We see that with SkyHub. As soon as you start using the SkyHub UI,
Okay, you mean the streaming?
everything, everything kind of goes to pot.
But actually, the GUI should stream directly from the SSD. I mean, it loads a video and the player should play.
And it's not just the video. It's not just the video. It's running the UI, right?
Yeah, of course.
But the suggestion about using a Pi 4 for the GUI is interesting. Yes, it might be a good solution for that. Because since this is not the priority of the Jetson Master, I think it could be good using a Pi 4 for all the displaying stuff.
Yeah. Okay, I'm doing a note.
Yeah, so to help getting as many developers as possible, it would be best if the development experience was, as easy on ramp as possible, right? So looking at the diagram here, it looks like INDI. So it is that's the platform really that provides a lot of the the sensors and the layer onto which we can add new code. And I'm just restating my understanding here. Please correct me. Can we have two instances of the same, two instances of INDI running, on a desktop computer?
Yes, you can, but there is no need for that. You just need one, and two there's no benefit from using two. I tried that several years ago, but just running one is enough because it provides the devices already. So why do you want to use two of them?
And if you're working on the communication, maybe MCP is outside INDI. So then, if you're working on communication between MCP and the all sky cam INDI, it's one. And if you're working on communication between MCP and PTZ Cam INDI, it's the other one.
No, the MCP doesn't talk to the INDI from the PTZ Cam. It talks to bt³s that handles everything else. And this is just, and there you have got not a very active communication, not an active data stream between the MCP and the PTZ Cam. It just gives commands, and the other things are handled by bt³s and the event manager. So the MCP is just for triggering commands.
Okay.
And the INDI protocol does provides the hardware interfaces and talks to the event manager. And the event manager does the image processing, or should provide the image processing, trigger the ML stuff, and so INDI is just a hardware abstraction layer.
Okay.
It provides the device.
Okay, thank you.
And it is actually a server clients thing. So actually you say the server provides all the devices and you put the client of INDI into your software. Is this true?
Yeah, you connect to the device through the INDI protocol.
Yeah, okay.
If you want to see that in action, there is an example in astronomy. We use car stuff with the ecosystem, and the ecosystem is some kind of observation platform. A mount is connected, several cameras, a filter wheel. You can connect. Normally I connect the GPS U-Blocks dongle to it, a weather station. You can connect about anything to it. And ECOS provides a way to use all that, and you can slew the telescope with it. You can take images and videos with that. This is already in place and working for several years now. So you can look at that, and there are some YouTube videos where people show how this is working. So you get an idea what INDI can do. You can have a look at indilib.org. So there you can see what is already in place. It's a good start. They have got tutorials. They've got the API there. They've got the Python stuff there, and use cases too.
So I dropped the link to the INDI in software development as with the software concept.
Well, I believe this is a meeting. I'm in a meeting. I'm in an international project.
Hi, Big Mac. Yeah, okay. So any other questions towards this direction of the concept, of parts of the concept, components, software libraries? Any questions in this direction? Okay, if not, then I think the next important information is what project management we are going to use. We scouted in the last couple of days a lot, tons of this stuff. And we finally found one which looks rather promising. And Christian, could you share your screen and show us shortly what ClickUp can do for us?
Yes. I have to look. I think it's the whole screen. Is it working?
Yes, I see.
Does anybody see? Okay. So ClickUp. We our thoughts were that we want to have a project management system that provides the possibility that every developer can take their task on their own. And the second main thing was that we want to have some kind of tree-style representation for the workload. And ClickUp provides other things as well, but the main things are covered. So we, on the right side, if you enter up ClickUp, you get such a view. This is the view of everything. You've got workspaces to the left. The space below is the one that is created as a demo just to have something running by ClickUp. I didn't delete that one because I wanted to look things up, so it's still here in place because this is just a test setup. We decided to take things apart and say, okay, every Jetson has its own space, and we set the data archiving things to a third one. So we've got the Jetson Master and the Jetson PTZ, and now since we highlight that one, we see a mind map view of what is already in place, that what is just filled in. Above here, you've got everything, so this will change to the point that if you click on it. But for now, we leave it as this. And here you've got the views, and you can add any view to it from this list. So you can use a Gantt graph or timeline or boxed. The board thing I will show later is the Trello stuff. Some of you may know that. You've got mind map. This is the one I'm using now, and even you can have even maps. And this might be interesting for all the stations we set up already, and therefore we can take a look and see where a station is and in what status it is. So this comes in handy too. And when we looked at it, we didn't know that, but I found it out later. So here you've got a representation of as a mind map. So you've got a layer where the spaces are. Each space divides into folders. They are indicated as folders here, and you can use other things like lists. One category down, you've got lists. In the lists, you've got tasks, and every task can be subdivided into checklists. So you've got a folder deepness of, let's say, 4 to 6. I think that will be enough. And because we do not have much more folder deepness, we said that putting every hardware board into its own space is a good solution. So we have now 3 spaces.
Christian?
Yes?
The point for the project management is to divide the whole workload, the packages, into very tiny chunks. Can you give some details, and especially how they are represented here?
Yes. Okay. What we wanted to do is that every task of coding should be divided down to small little pieces. We call them chunks. If we start here, let's say we want to have ZWO-ASI support with INDI, and want to take this camera here, then we can say, okay, what do we need, or what do we want to implement? What is the task that someone should do? So GStreamer layer would be nice, or like here, creating a video output is necessary. Then we divide all those tasks into pieces that can be done within 40 to 60 minutes, because we are not professionals that are paid for. We are enthusiasts. We do not have, let's say, 10 hours per day to spend for this. If you do and you want to contribute in that way, go ahead. But the normal people in the normal life do not have that amount of time to spend for it. So 40 to 60 minutes, yes, within that time you can do the one task or another, and so you can take that task, work with it, and provide the output. That's why we wanted to have a project management system that can do that can subdivide things. As you can see here, this is just an example, and we have to go down and define those tasks that will start within the next.
So
Um,
the idea
yes?
is that a contributor who is registered with us on ClickUp or gets an invitation from us for ClickUp can go there, look up the mind map or any kind of different view, whatever you prefer, but then finally find the work package, which is a 40 to 60 for in average a work package, and say, okay, this is something I can do. I have 1 hour time, so I pick this one. Is this true?
Yes.
Okay.
I'm going down to the task ZWRZ, and I click on it to see this. This is the list view provided, and in the list view you've got those two tasks. If you open one,
There you have the description and so forth. Yeah.
yes, you've got this descriptions here, and we're planning on describing what should be done in this task exactly. You can use a checklist that can be created. Let's say this is checklist, and you can create some more. And there we should write down all the options that a task should have, and this is the subdividance for the main task here.
Okay. So because of time, Christian, we have to stop here. I have one
Yes.
last question for any contributor who wants to be added to the ClickUp Sky 360 environment, has to deliver us an email address so we can send the invite to. But Christian will set up the project. This is just demo now, what you were seeing here. This is nothing at all. It's just for playing around and testing it out. So Christian can you give us any idea of time frame when we can expect let's say a final, a version implemented here in ClickUp?
Since I've got another program running for the next week, so I will do both projects at the same time. I think it will take at least up to Friday. That the setup of ClickUp for usable in a usable way will take up until Friday. But
I would
since
even
then.
I would even propose something different. I would say, why not meet every second Sunday here in the Discord and talk about what we have and where we stand. So actually you would now have 2 weeks to go until in 2 weeks Sunday you present the setup in the ClickUp. Would that be feasible? Doable?
Yeah.
Okay.
Of course.
Good stuff. So guys, I want to finish this session for now. I just stop the recording.